Well, hi, thanks for joining me as we take a look at IB practice number 2. This one is dealing with a little spinner. So in an earlier problem, number 10, we had Priyanka and Jorge that were pulling discs out of a bag because they were stuck at home and bored, so this is what they did. Well, I don't know, maybe Priyanka and Jorge got bored of pulling discs out of a bag, and so now they're going to sit here and spin a spinner all day long. We're just going to spin this spinner. So let's see some probabilities of spinning this spinner, because this is what we're going to do. All right, so the diagram shows a circular horizontal board called a spinner, divided into 6 equal sectors. The sectors are labeled white, so here's my white with the W. Yellow, I've got 2 yellow sections labeled with the Y's, and blue, with my 1 blue section down here labeled with the B. A pointer is pinned to the center of the board. Here's my little pointer right here. And the pointer is to be spun, and when it stops, the color of the sector on which the pointer is stopped is recorded. The pointer is equally likely to stop on any of the 6 sectors. That's important to remember. So, I've got 6 pieces. This circle is divided into 6 equal sections. And I've got this little spinner, and I'm going to spin the spinner, and the spinner is going to go around and 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 stop over here. And so then, it stops on white. Or maybe I flick the spinner again, and it goes around and 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 around. Maybe it stops over here on the yellow next time. So this is what we're doing. So they've got a tree diagram for us down here, but I'm going to actually think first. I know it doesn't say to do this in the problem, but just my thought process. I kind of want to get a feel for what these probabilities are. So what's the probability that my spinner is going to land on white? Well, how many of these sections are white? Well, 1, 2, 3. And how many total sections are there? There are 6 total sections. Now remember, the key here is they are all equal. If these sections were not all equal, we couldn't do it quite this, it wouldn't be quite this straightforward. But since they're all equal, 3 of them are white, we have 6 total. This means the probability of white is 1/2. Alright, well what about the probability of yellow? Well, I've got 1, 2 yellow sections. I've got 6 sections in total. This will reduce, and I get 1/3. And what about the probability of blue? Well, I've only got 1 section that's blue. There are 6 sections total. So that's just going to stay 1/6. So that's how I get my probability of landing on each of these sections. So now, they've helped us out, and they've actually given us a tree diagram to use. Now, what do you notice about this tree diagram that's different from the other tree diagrams that we've worked with, and maybe more intimidating? If you notice, this was one of our previous problems, and this was the tree diagram we had, and now this is the tree diagram we have. Oh my goodness, there are 3 branches off of each of these vertices. Holy goodness gracious. You know what? That's okay. We can deal with that. It turns out, you can have as many branches as you want. So, each of our little vertices here, they each have 3 branches, because guess what? There are 3 different colors. So there are 3 different outcomes that could happen. I mean, you could have tree diagrams that have 10 branches, that have 20 branches, that have 100 branches. I mean, those would be really tough to draw, but it's possible. So we're not going to worry about the fact that this looks more intimidating because it has more branches. We're just going to use what we know about tree diagrams and work with it. And we're going to be okay. So let's take a look. First of all, the other thing I wanted to point out here, are these, spinning this spinner, are these spins going to be dependent or independent? And why? If you are thinking these are independent, you are correct. Because if you think about it, each time you spin this, spin, and then you spin again, every time you spin that, the probabilities always stay the same. It's not like you spin once and then all of a sudden, like, the colors on the spinner change and then you have to spin again. Like, the spinner stays the same every single time, which means your probability stays the same every single time. Nothing changes. So you'll notice there's definitely a pattern that happens in this tree diagram. 1/6, 1/3, 1/2. 1/6, 1/3, 1/2. 1/6, 1/3, 1/2. 1/6, 1/3, 1/2. Because our probabilities are always going to stay the same. Again, because these are independent or not dependent events. So let's take a look. Part A. All right, part A, here we go. Find the probability that both spins are yellow. All right, let me put this up so you can see. I keep losing track of my, my window here that you can see. All right, so I want the probability of yellow, yellow. All right, so what goes in between the yellow? I need yellow, yellow, but what's the magic word that we're going to put in between those? If you are thinking and, you are correct, because in order to have two yellows, I need a yellow and a yellow. So I need yellow and I need yellow. If you can write these probabilities and use the ands and the ors, you are going to be set up for success. Usually the place I see a lot of people run into problems is when they just try to write down yellow, yellow, and then they try to work with that, and then they start losing track of what math they need to use. So if you make sure you use the ands and the ors, you're going to start setting yourself up for success. So let's see what we got here. Yellow. What's the probability that the first spin, so here's my first spin, what's the probability the first spin is yellow? Well, here's my yellow, so go across that little branch. The probability I go across is 1/3. So my first y is going to have a probability of 1/3. And, again, what does and mean to do? Multiply. Now, I'm already at the yellow, so I'm already at this vertex. Now I need another yellow. So where am I going to go? Over here to yellow, and that's my other 1/3. So 1/3. So I have 1/3 times 1/3. Now, I didn't mention this in my other videos. Maybe I should have, but I'll mention it now. Make sure when you multiply fractions, remember fractions get multiplied going straight across. So 1 times 1 gives me 1. 3 times 3 gives me 9. So my probability of getting yellow and yellow is going to be 1/9. Now, you can convert that into a fraction if you would like. Because my probabilities are given to me, you can convert that into a decimal if you'd like. Because my probabilities are given to me as fractions, I'm actually going to leave them alone and just let that stay a fraction, and I'm not even going to mess with that. And there you go. That's the probability that you're going to spin yellow twice. All right, so use this information. Take a look at parts B and C. Give them a try, see what you come up with, and then come back and check my videos. And if you get stuck or need to check your answers, I got you. I'll help you out in the next videos.